Okay, so today we're going to be looking at comparative pie charts. So, what we have here are two pie charts together showing where teachers and travel agents have traveled to, and each sector represents the continent. So, for example, we have the continent of Europe as a very big sector for teachers. We have the continent of North America, South America, so on, for both. The question we've been asked is, did more teachers go to North America or more travel agents? So what we're looking at is these sectors for North America. Now, at a first glance, you would say more travel agents went to North America. Is what you'd love to say, because what you can see is that the area of this sector for travel agents is going to be bigger than the area of this sector for teachers going to North America. So you would like to come to the conclusion that more travel agents went to North America than teachers. However, these are just pie charts. Pie charts from what you've learned from primary school, year 7, year 8, year 9, all the way up to year 11. It's mainly in foundation GCSE maths, but you may see it in a higher GCSE maths paper. So I'm sure you're familiar with pie charts. And you'd love to think that more travel agents would go to North America because it has a bigger angle here, 63 degrees, in comparison to the angle over here, 48 degrees, and it has a bigger sector overall. But that is not how pie charts work. Pie charts are used to compare proportion only. You can only compare proportion. So you can be like, a bigger proportion of travel agents went to North America than teachers. But you can't say more travel agents went to North America than teachers, because you need to know the sample size. That is the one thing you need to emphasize with statistics. You need to question, why is it wrong? And usually it might have something to do with the sample size. If we don't know what the sample is, we cannot come to these conclusions. For example, I could have sampled only 100 travel agents, whereas I sampled 300 teachers. So if I'm trying to figure out how many teachers went to North America, I could take my 48 degrees out of 360, and I'm going to times that by 100. So if I do that, 48 over 360 times that by 100, that gives me 13. Oops, I times it by 100. I meant to times it by 300 because the sample was 300. So let's do that again. My bad. Gives me 40 even. 40 teachers travelled to North America if I use a sample of 300. Now, if I use the travel agent sample size of 100, I'm going to get this correct this time. 63 out of 360 degrees times by 100. I've got 18 travel agents went to North America. So as you can see, even though the sector is bigger for this, that there's like a bigger proportion of travel agents going to North America, when you actually get the sample sizes that I just made up from the top of my head, you can see even though this sector is smaller, you still have more teachers going to North America than you have travel agents. It is all dependent on your sample size, and pie charts can't help you compare frequencies. Frequency basically means number. So key things, pie charts can compare proportion. So you can compare like fractions in a way, but they cannot compare frequencies. Unless you are given the frequencies, you cannot do that. For just normal pie charts, you cannot compare frequency, you can only compare proportion. That is why comparative pie charts exist. Comparative pie charts are like pie charts, but even better, because you can compare both proportion and you can compare frequency. Because what you'd have is your area, oh my god, not crossing it out, my bad. Your area is going to be directly proportional to the total frequency. So if I have my area is 100, we know it's going to be directly proportional to our frequency. So 100 is going to be our frequency times some proportional scaling factor k. So in more general terms, our area of our comparative pie chart is going to be our frequency times k. And this k is just like making it proportional. So it's going to be some fraction or some number. So I might just write some fraction. And this k thing is what keeps your area not equal to your frequency, but it keeps it proportional to your frequency. So let's have a look at how we're going to use this. The pie chart has a total frequency of 60 for teachers and 40 for travel agents. Let's choose a radius of 6 for teachers. So here we have our comparative pie chart for teachers, and we have just chosen 6 as our radius. Like, the radius for one of them can be completely random, as long as for the other one, they are in proportion to each other. So if I look at my area for teachers, you know, your area of a circle is going to be pi r squared, so 36 pi centimeters squared. That is the area for teachers, and we got that because it gave us a radius of 6 for teachers. But we're thinking of what would the area of the pie chart for travel agents be. So there are 40 travel agents, and we know 40 out of the 60 teachers is going to be 2/3. So what we're trying to say is this is our proportion thing. We know that if our area for teachers is 36 pi, the area for travel agents is just going to be 2/3 of that area. So if I do 2/3 of my 36 pi, you get 24 pi as your area for your travel agents. And that's all that is. It's just using proportions. So let's do a few more examples to get the hang of it. We have 90 adults and 60 children are asked to take part in a survey. A pie chart is drawn for the adults' results using a radius of 7 centimeters. So we know for adults, the area is going to be pi r squared, which is 49 pi. Now let's think about children. We know for children, there are 60 children in comparison to 90 adults. So when we're trying to find the area for children, we're just going to take the area for adults and we're going to times it by 60 out of 90, which is 2/3 times 49 pi. And that gives us an area of 98 pi over 3. So using our proportional scale factor, we have gone from our adults area to our children's area. Let's try it again. 80 adults and 110 children take part in a survey. A pie chart is drawn and the adults research and the adults results using a radius of 7 centimeters. Let me try and read that again. That was all over the place. 80 adults and 110 children take part in a survey. A pie chart is drawn for the adults results using a radius of 7 centimeters. So we know for adults, the area is going to be pi times 7 squared, which is 49 pi. And we know for children, we're just going to times it by our scale factor. There are 110 children in comparison to 80 adults. So we're going to times our area by that, 110 over 80, times by 49 pi, and that gets us 539 pi over 8 for children. And then let's try this one more time. 90 adults and 120 children take part in the survey. A pie chart is drawn for the adults and for the result. Oh my god, these questions are so hard to read. 90 adults and 120 children take part in the survey. A pie chart is drawn for the adults' results using a radius of 7 centimeters. So for adults, we've got pi 7 squared, which is 49 pi. For children, we know the fraction is going to be 120 children out of 90 adults times by 49 pi. And that gets us 196 pi over 3. So it's that easy. It is literally finding the area of a circle and then scaling it depending on your sample size to find the area of a different pie chart. So going back, having a look at my answers to make sure they're all consistent. And they all seem to be. Okay. So key thing is, when you have a comparative pie chart, because you know the area is proportional to the total frequency, you are able to compare frequency and proportion. So now, I want to go that extra step further, and I want to find the radius of these answers, the radius. So we know the radius for adults is 7 centimeters. What about the radius for children? So what we need to work backwards is we need to start by writing pi r squared is equal to 98 pi over 3. And then we're going to rearrange to find the radius. So what I'm going to do is cancel out my pi's. So I get r squared is equal to 98 over 3. And then to find r, I'm going to square root my answer. Square root of 98 over 3 is 5.72 to 2 decimal places, centimeters. Going to do the same thing over here. Pi r squared is equal to 539 over 8 pi. You cancel out your pi's. So you get r squared is equal to 539 over 8. And then you square root your answers. So 539 over 8 all square rooted. And that gets me 8.21 centimeters to 2 decimal places. Okay, same over here. We want to find a radius for children. Pi r squared equals 196 pi over 3. You cancel out the pi's and you get r squared is equal to 196 over 3. So your r is equal to the square root of 196 over 3. So 14 root 3 over 3. And that is 8.08 centimeters to 2 decimal places. So we've got a question here, screenshot and have a go. And we have a question, this big question over here, which you can screenshot and have a go at. What I'm going to do is I'm going to do a follow-up video showing you a different method to find your radius for your second comparative pie chart. And what I'd like you to do is pick a method that you prefer and stick with it. Personally, I prefer the method that I'm going to show you in the second video, but this one shows you how it works, and the second one shows you how to do it quickly. So, thank you for watching.